Hey, so I was just going to make this quick video for you to give you an understanding of how Git works and some command line stuff just in case you didn't know some of the certain command line things. So yeah, let's get started. I'm going to make a new directory called test really quick and change into it just so that I don't ruin anything in my root directory. I'll make this a little bigger just in case it's hard for you to see. So Git is version control software. There are certain things you do with it to make sure that everything's done in an organized fashion when you're making something on, say, GitHub. And the git command is always just git and something else here, which is going to be, and there could be more things beyond that, but there's going to be something here that you type in. So it's always git to start. You can always see which git are the most common git commands by just typing git and hitting enter, and then it'll show you all the most common things. This is called your usage string. So git and then all other things. So like git add, move, restore, remove, clone, init. Log is important, status is important, branch, commit, merge is kind of important, switch is not really that important, fetch, push, and pull are important. So what I want to show you how to do is just how to use sort of common git stuff. So what you saw me do there was just a clear screen. On the Windows command line for command prompt, it's CLS. If you're not using the command line, if you're not using command prompt, you can just type clear. Or you can optionally do Control L, which would look kind of like that, right? Control L then just clears the screen. So if I just hit enter here just to show you that, and I type clear, it clears. Or if I hit enter here and hit Control L, it clears. If you were on command prompt, you could just do CLS, which means clear screen, and that clears the screen. I'm just going to clear it really quick. So you can see right here, some common shell commands are pwd, which stands for print working directory. You can see I'm in my test directory here, and I already showed you make directory, I think you knew that one, and cd, which is change directory, and then rm, which is remove, So the first thing when you make a Git repository is you git init, and what that does is just initialize the Git folder in this current directory you're working in. You can see it says initialize empty Git repository at users whatever .git. If you want to see what files are in the directory you're working in, you can type ls. However, this might be a hidden file because it's a dot in front of it. This is a hidden file, so you'll have to do -la, which stands for list and then all. If I do -la, you can see over here we have the Git hidden folder right here. And if you were always wondering why doing cd ... makes you go back up a directory, that's because it is actually hidden right here, and that represents the directory above which you're working on. And if you ever do cd ... well, it just trains a directory into the directory you're currently in. I'm still in the same one, as you can see by here by my prompt. So that's why these two things exist here. And like I said, here's the Git folder. You never really need to change directory into it because all the stuff you're going to do using the git command references functionality in here that you don't need to reference manually. So I'm going to do everything in Vim so that everything is contained within this window, so you can see kind of what a normal workflow might be if you were going to commit to a repository on GitHub. So first thing I'm going to do, I'm just going to make a file. We're going to do this in C, or it doesn't really matter, we can do whatever. We'll do it in Python, test.py. This is just Vim, and we'll just make a quick thing here. And we'll save and exit, and then you can see we do Python test.py. Right, I'm on Mac OS, test.py. It does hello. Yours would be Python test.py. but I'm on Mac OS, so it's Python 3 because I'm using the third version of Python. If I was using Python 2, you see, well, I don't have it installed, but that's why there's a 3 here. It's just specific to Mac OS. So anyways, you can see this works, and I'm gonna make another one called test2.py. This is what I was talking about earlier today, where I was saying you can do if name equals main pass. And all that does is just says if you were to run this file, nothing's going to happen. So we can do Python 3. Again, it's for you, it's Python, but here Python 3, test2.py, and nothing happens because I told it to not actually do anything with the file. So I'm going to clear the screen here. Again, it'd be CLS for command prompt, or clear, or Control L in PowerShell for you. So again, we'll just list everything out. So you can see we have two things now, test.py, test2.py. I'm going to clear the screen again, and then ls-la to show you that we're in the same directory as our Git folder. This is necessary. You must be in the same one here, or any subdirectories. So if I was in, you know, test2, cd test2, you see I'm in nothing, and if I do cd, or if I do ls ... which means look at the directory above, you can see we're in the test2 directory, current working directory, yep, test2. If I do any git things in here, still works just fine, right? So let's ... back up and clear the screen. So the first one you're always going to want to use, you're going to be using the most, is git status. Git status basically tells you everything that's going on with your current repository you're working in. So the first thing is always going to be what branch you're on. I'll explain what a branch is in a minute. If you have any commits, we don't have any, of course, because this is a brand new repository, and what files have been modified. In this case, these are called untracked files, and I'll explain to you really quick what that means after we make a commit. But the first thing you'll do after you've made your changes and you've done git status to see what changes you have made, you can do git add, and then as you can see here, it's always, we'll print this out. You can, let's say we want to add test.py to be committed. We execute that, and then I'm going to clear the screen, git status. You can see now changes to be committed. Test.py is now a new file, like it says. It means it's existed in the repository before. And yeah, so let's go ahead and commit that. So when you commit something, it's only going to be files that you've added, which is another word for that is called staged. If you want to remove something from being staged, you could just remove it. This is not the normal command you'll see because this is a new file, so you'd have to do git rm -- cached. If it was a normal file, like let's say you had test.py and you just made modification to it, it'd be git restore -- staged, and then the name of the file here. And I'll show you that. So let's commit this. Git commit -m. This is what you're going to always do. You always want to add the -m flag because what it allows you to do is add a message. So you can see here, we can add anything in between here. Let's just say commit 1. Now you can see this is the name of our commit. We're on the main branch, which I'll explain in a minute. And we changed one file and had 2 insertions in that file, which was in test.py. Create means the file never exists anymore. This was a modified if it didn't exist. So now I'm just going to clear the screen really quick, and you do git status. And you can see here that now we only have one thing left, which is just test2.py, because it's been modified and has not been committed. What I want to show you is what happens if you just modify something. So let's go back to test.py, and I'm just going to add some new line characters in here, and it'll think that I modified it. Now we can do git status. You can see here, this is the difference what I was trying to show you. So if I scroll up, you'd see normally, where was it at? Yeah, so it just says untracked files here. Here now, of course, it's modified, so it'll say it's modified here. And this is what I was getting at when you, let's say I add test.py to be committed. If I do git status, you'll see this was the thing I was talking about, git restore -- staged, and then the file name. If you've added something that's already staged. which is what you do when you add something, when you do git add, and then the file name, that's adding it to the stage to be committed. Or you can see here, if it isn't staged, but it's just modified, you can do git restore. Actually, just to show you that it's the same, test.py, right? You see these new lines that I have here. And then we can do git restore test.py. And what that does is it reverts it to its previous state. So if I do git status again, that didn't do anything because it's staged. So restore -- staged test.py, git status. So git status is your friend. And you can see now it's not staged for commits, but it still has the changes that I had. But let's say I just want to discard the changes, right? So git restore test.py, and now git status again. And you can see nothing there. And if we go to test.py, those new lines are now gone. So git status is your friend, git add is your friend, git restore, and optionally -- staged, and git commit, always do the -m. That's important. So those are the main ones you'll be using most of the time. Now, you can see here that we still have our commits, our changes for testpy.2. That was just for demonstrative purposes, so I'm just going to remove it. Test2.py. Now if we do ls, you can see, what did I accidentally make another file name? Oh, right, that was the directory. Test2. So this is a Unix command, meaning like Linux and Mac OS. On Windows, I believe it's rmdir in the name, and then that is how it works. So now we're back where we were, right? We're just test.py, git status really quick just to check things out. And you can see we're on branch main and nothing to be committed. We're on a clean working tree, which means that there's no changes. So now I'm going to explain to you a little bit how branches work. So you can always check what branch you're on by doing git branch. You can see here I'm on the main branch, which is always the one that will be done by default, and you can tell I'm on the main branch because of the asterisk. You can make a new branch by doing git branch and whatever the name of it is here, the name you want it to be here. So I'm just called new branch. Again, we can do git branch, and you can see now we have main and new branch, except for I am currently in the main branch, so there's no asterisks here. So basically the reason why you'd have multiple branches is, let's say you're working on multiple features at the same time. You may want to add a branch for one feature and you may want to have another one for another one. Typically, you're never working on changes in the main branch. The reason for that is so that you don't accidentally commit to it on the remote repository, because it's a lot harder to get rid of changes once you've committed in the remote repository than it is to do it on a branch that isn't the main remote repository. So if I was to commit to new branch and this was a remote repository, well, new branch is going to be based off of main. Like we have some sort of we have a branch here. This is the main branch, and then we branch off here, right? That would be I guess I could kind of do. We have our main branch here, right? And we can then go and branch off of it here. And then this, we can call this would be new branch, right? This is our main branch. If we were to, make any changes here that we messed up on or something, well, we could just remove it without worrying about the main branch. But the main branch is our lifeline. So if we screw it up, it's a lot harder to fix. That's why we always want to have a new branch. And the idea of branching is that you can make, another branch. Say new branch 2. That is now based off of whatever the current changes are in new branch. So basically, branching is how you make changes to something at a current point in time. So this means even if main progresses all the way out to here, well, your branch changes will only be what you've done starting at this point and the modifications you made starting at this point. So main can continue working, so other people, you can have Billy Bob Joe working on up here, and you can still be working on your stuff, and later on what you can do is you can say, okay, now I'm done with my work. I want to merge it into main, and I'll show you what that's like. So we have, this branch here. Now we have to merge into main, and that's more of an advanced concept, but it's just a good idea to kind of understand how branching works. So now these branches are essentially useless and we can remove them, but all your changes that you made throughout this time is now going to be put into main whenever you decide to merge them together. So with that out of the way, again, get branch shows you the branches you have, and I made that new branch. If you want to change to this branch, right, you just do get checkout, which means change your, to a new branch, and then new branch. Now you can see it always says switched to branch, new branch. So there is a faster way to make a new branch and check out to it than what you see here. So the way you can do that is by, and just to show you again that we are in branch, you do get branch, you can see now this is the one that's being selected. If you don't want to do get branch and then get checkout new branch because it's kind of redundant, you can do a little shortcut by doing get checkout -B, which means make a new branch of this name right here, whatever you name it, and check out to it at the same time. So it's just new branch 2, and now I'm checked out and I'm switched to a new branch. You can see here it just says switch to a branch. So now we can do get branch, and there you go. Now we're on new branch 2. Now let's say that you want to remove a branch. Mind you, this is permanent, so if you ever mess this up, all the changes you had on it are never going to be able to go away, or never being able to come back. So do this with caution, but you can do get branch -D. Let's just say we're going to remove the new branch field. Now it says deleted new branch. This is the commit ID that you deleted it at. Yeah, so now if we do get branch, we can see only new branch 2 remains. And I'm going to get checkout back to main because main already exists, so there's no reason to do the -B flag. Switch to branch main, and now I'm going to remove the other branch. And you can see we deleted the new branch, clear the screen, get branch. Okay, now we're back on main and where we were. And for example, if you want to see what changes have been made, like you saw back in that text file I was making, maybe you've made changes and you want to see, you can do get log, and that will then show you, well, I have made one change, and this was the date. This was the commit message. So that's when I showed you this. This information that I had here, in this case it was commit 1, is shown right here. That's why it's important to have that message. Another thing you just saw me do intrinsically, because I don't even think about it, is doing Control-C. So if you do Control-C, it'll just, if I type anything and I hit Control-C, it'll just nuke whatever I was doing here, even if it was running currently, and it will then make a new line and give me a new prompt. Clear the screen really quick. Okay, so we're still in the main branch. We've made a change. Now, let's say that we want to commit this to a remote repository, like you might want to do on a shared, sort of thing, like a GitHub repository, like say SpecTrack. So I'm going to go over here to GitHub, which you have to make an account really quick, and I'm just going to make a private repository just to show you what this would look like. So your repositories, I'm going to make a new one, private. Test 1, okay, cool, and create repository. Whenever you create a repository, it's going to show you two things. if you want to create a new repository on the command line, you can just copy all these commands and it will basically set up a repository, add a README, which is basically just a, hey, when you open this repository, you should look at this first. This is going to give you information about what the repository is. And then, it'll make your first commit for you, as you saw here, as you saw in the command line like we did. So get init, it adds the README, it commits it with the message of first commit, and it makes sure you're on the main branch. You don't need to really ever do this. And then it adds the remote repository using the URL and then pushes it to main. For us, we were just going to add the remote repository. So I'm going to copy this really quick and I'll show you what these mean in a second. So back to the command line, I'm just going to paste this in, and what this says is we want to add a remote branch by doing get remote add, and then we're going to name it origin. You always typically name it origin. Just keep it that way to make things simpler, and then you take the actual URL of the remote repository that you want to add. So I hit enter, and you can see now we, no errors, and we can always check if we have a remote by doing get remote. And you can see origin, right? Because that's what we named it. So here comes the idea of pushing and pulling. So to take your commit, right? We can see here we did get log. To take your commit and push it to the remote repository, you can see that, or you will need to do git. You'll need to do git push. And what that means is push to the remote repository you have it set up to. So this is a little bit of a tricky part. When you have a branch, your branch is set up to track, quote unquote, that's what the name of it is, a certain branch on the remote repository. So if, let's just say, right, the main branch here doesn't even exist yet, right? That's why it's showing this setup thing here. I'm just going to move this so I don't have to keep going over it. There we go, really quick. So once we make a new branch, let's say, or something like that, we need to push our changes to the remote so that everyone else can view it. However, we can't just do git push because it's going to look at our current branch, which, remember, is main, and say, does main have a remote repository branch that it is currently tracking? If it doesn't, it's going to complain. So if I do git push, it's going to be like, hey, the current branch has no upstream branch. If you want to set an upstream branch while you push, you can do git push -- set upstream origin main. You can also set this automatically. Don't worry about doing that. I'm going to clear the screen really quick. I'm going to show you the normal command that everyone uses instead of do the -- set upstream, because that just takes a while to type out. You can do git push -u, which means set upstream, origin, and then after this, so you always have to have origin because that's the name of our remote. After the slash, this would be the name of branch you want it to track, right? This can be anything. So you can have any remote repository branch be hooked up to any local repository branch. Obviously, the common wisdom is you want to just use the same naming, just not confuse yourself. So the shorthand is just doing origin, and what that will do is it will take whatever the name of your current branch is, I'll show you again really quick, which is main, and take that information and use it to push to GitHub. So we're going to do git push -u origin, and then that will, we'll have to do origin space main because we're setting up the remote path. Actually, I don't even know. Do I need to do that? Yeah, you do. Okay, I'm pretty sure you do. So we're saying we want to push to the remote branch. We're not giving it a specified name, like I said that you do right here. And we're going to set it up to our main branch, which is our local main branch, right? This guy, to track whatever the remote main branch is. So I do git push, and you can see here, it's going to, push to main. You can see it basically figures out all your changes that you've made. And you can see right here, here's our remote that we have set up, which is origin. And you can see here's the important information right here, these two lines. You have a new branch which was made, right? Because a new branch on the remote, that's an important thing. So what you see here is it says main is now tracking main. or in words here, branch main is set up to track origin/main. So origin is the remote, main is the branch that it now is on GitHub. Now if we go over to GitHub, we refresh, now look what we have, test.py. You see we're on the main branch here, and that has our changes in it. So that is the idea behind a remote repository branch. So I am going to also make another branch and show you that you don't just have to use the naming here. So let's do git checkout -b, another, let's just call it B1. Now we're switched and checked out, and I'm going to, let's see, let's make a new thing, test2.py, and I'm just gonna add garbage in here because it doesn't matter. And I think we're good. So git status, of course, you can see we have testpy.2, git add test2.py, and you can do git status if you want just to verify it's there, git commit -m, another commit, and you can see we have test2.py, which is just committed, and we can do git log and see, oh, now we have new information. Another commit is on here, we can see our time, and here are some important information if you want to see the history of what's been committed. You have origin main, which is sitting right here, which is tracking main, right, as we did set up. And then you have your B1 branch we just did, and head is like, this is what you're currently viewing. So head is pointing to B1 because that's what the current branch we're on. If you were to scroll back a bunch and look to here, I'm going to try and find it, you can see head is main. So it's changed now, and head is B1. Okay, git status, and you can see we're on branch B1, nothing to commit because we just committed it all. And we want to push it to the remote repository. Let's say in a circumstance that you are unsure of what your remote is for this specific branch. You can do git branch -vv, and that will show you information about your branches beyond just git branch. We're on the B1 branch. You can see we just committed. That's our last commit name or message. This is our last commit ID. Not very important necessarily for you to understand. And then we have our other branch main, and you can see it's tracking origin-main, and you can see that we are on commit 1 for that other branch. So this is the idea of where we have one branch that is branched off of main, starting at commit 1, but we have made changes, and now we are off down here, and main is over here. So we want to push that to main, right? Or we want to push that to our remote repository. So very simple, git push -u origin, and then let's just say B1. That'll be the name of the remote, and again, that means this is the name of our local, and that means again make a remote branch with the name B1, right? So git push -u origin B1. So now there's some new information you see here, and you see the old information. We made a B1 branch that's tracking the remote B1 branch, and you can see it in plain English here. B1 set up to track origin/B1. This is the idea of pull requests, and this is how you get into merging. So let us do that really quick. So when you see this create pull request for B1, pull is a really bad name for it. What it should be is a push request. But basically what this is, you can control click on your keyboard this, and it should bring you to your browser. And this will open, see we're back on the GitHub page, and you can see in here we have code and pull request. These are the only two you'll be curious about using. So here's a pull request. And basically what we're trying to say is we want to merge B1, whatever the changes B1 is, into main. So we can set up a pull request, and what that does is say, I want to make these changes and put them into main. And you can set up people to review those changes, and this is just for like project management if you have a large project. And so let's just create the pull request. This is how you'll normally be putting stuff into a branch. You can see here is our another commit, and that's the commit ID. And you can also see right here again that we want to merge, in this case, one commit into main from B1. And if you want to see what changes have been made, you can click on a certain commit, or you can just click on files change, and you can see we added just garbage here. So normally what we do is, since there's no conflicts, because let's say, I'm going to express what a conflict is really quick to test. So again, we have our canonical thing where we have main here, and we merged off, and now we're here. And we made B1, and we want to merge B1 into main. Luckily, in this case, nothing has been changed on main. But what happens in the case that something has been changed? And let's just say at this point here, someone committed something. We don't have those changes in our B1 branch, right? Because we are not tracking the same remote branch. So in order to fix that, we have to merge B1 into our branch and fix the conflicts before merging into main. So I'm going to show you what that looks like. So again, we're at B1 here, and you'll see I'm going to make a change to main. We can go back to the code thing so you can see what I'm talking about. Don't worry about this. We're on main here. Again, if we were to go to B1, you can select branches by going to here. You can see we have test2.py. And you can also see here that branch 1 is one commit ahead of main. So what I'm going to do is I'm going to make a change to main and show you what happens. So we're on B1, and we're going to change to main and make a change. So git checkout main. And, I'm just going to tell you when to main, and obviously it's always going to tell you if you're tracking a remote branch, if it's up to date with a remote branch. And luckily we are. So let's make a change really quick. So let's git add, test3.py, git commit, git, and then git push. And because we set our remote branch, right, to main, I guess that also works somehow. Actually, that's not what we want. There we go. You can see that we have main as our tracking branch. The one that we are one commit ahead of main, which means that we are, we're further down the chain than what the origin main is, which is our remote branch, and our commit name is he. So here, let's just go git push. We already have our remote set up, so we can just push, and it will go right to main, as you can see. And we can go over to main here, refresh, boom, there's test 3. Now here's a problem. Oh yeah, well, there's no conflicts here. So basically when you have no conflicts, it will merge regardless. So what I'm going to do is I'm going to vim test2.py, and I'm going to put obvious garbage in here. And we know this already exists, so this wouldn't really be a valid use case, but or this wouldn't happen very often, but let's just go ahead and do that, and then let's push. And now we pushed. Now let's go to code, and you can see we have test 2. And this has garbage in it. So we can go to our pull requests, and you can see, hey, now this is what we wanted to see. This branch has conflicts that must be resolved. So what this means is that we have made changes. The branch that we want to merge into has changes that we don't have in this branch. So in order to fix that, we need to merge main into our branch, right? So that means go down into, if you can think mentally of that diagram, we need to go down into our branch here, bring those changes in, fix them if there are any bugs that happen from them, and then go back up and push it into main. This is just telling us on the remote side of things that there are conflicts. Of course, these conflicts always existed on the local side of things. It just doesn't tell you automatically. So for example, let's go ahead and check out to B1. And we can get status really quick, and obviously we're up to date with origin B1. Nothing to commit because we didn't have anything to commit. So we want to merge origin main, right, into our branch and fix the merge conflicts. So we can do git merge origin / main. And what this means is merge origin main into our branch. In this case, we could also do just git merge main because we have them our remote branch, but it's always a good practice to do it from the origin main because someone else could have made changes and you don't have them yet. So we'll git merge, and you can see here, auto merging, there's a conflict, right? So we have to go fix that really quick. test2.py. Actually, I'm going to open this up in VS Code so I can show you a little nice thing about VS Code that it has. Here. So now we're in VS Code. I'm going to make this a little bigger so you can see it. So this is a really cool thing about VS Code. A lot of the stuff I've shown you can do on the command line, you can do in VS Code, which makes it a lot faster. I'm showing you how to do it in the command line because it's good for your fundamentals. So here's what happens. You can see by the exclamation point, we have a merge conflict. We have to fix it because we have to make sure that, you know, the main branch has in it what we want to have in it. So what you can see here is what is on origin main. It's just this gobbledygook that I typed in, and you can see it's called the incoming change. And you can see what is at our head, right, which is at B1 currently, and that's our current change. We need to choose between the two, select that, and then overwrite what's on main, right? You know, we're going to basically select one of these two, and then whatever we commit to main is going to be what's on there. So let's just say that we want to overwrite what's on main and select accept our current change. We can click that, save, and we can go back to the command line, and you can see git status. And now I have unmerged paths, git merge. Git add. Is it like git merge continue or something? Okay, there we go. So, I just forgot exactly what the order of operations are. Basically what you need to do is you make your changes and then you commit them to your branch, and now we have remote changes that we have local changes that the remote does not have. So we can do git log, and I'll show you that. So here's kind of how you read the log. We have where origin B1 is, right? He was committed in FJ was committed, whatever. That's where main is. Of course, main is ahead of our branch on our remote origin, our remote B1 branch. So we needed to commit that up and fix those, merge those in and fix them. So now you can see our commit log as we've gone past what was on main, and we fixed that. And you can see here I have the fix merge thing, and our head's pointing at B1. So now, by the way, if you're in git log and you want to get out of it, you can see this little thing. Just click Q and it'll get you out of there. So now git status, and what this means you can see here is that your branch is ahead of origin B1 by 3 commits, which basically just means that we have changes, right, that B1 on origin doesn't have that we do have. So quit and git status, of course, again, just to show you once more, and we can just do git push, and that will then push our stuff to a remote repository. So here you can see now we have our fix merge, and we're ready to merge into main because there's no conflicts. Typically, before you do this, we need to make sure everything functions, but we're just going to merge it in because none of this matters. And there you go. Your pull request has been successfully merged and closed. So now you can just delete the branch because we don't need B1 anymore. And look, there you go. Now we have test2.py with just the garbage of nothing in there. And there you go. So now that remote changes have been made that we that we don't have that we want to have, another thing you'll do a lot, typically when you know someone's made a remote change, is you're going to do git fetch -- prune. This is an important thing to do just in case someone deletes a branch like I just did. Basically what this means is fetch all new changes, and if there are any branch from all branches, and then if there are any branches that got removed, remove them. You can see here there was a change because I deleted origin B1, and of course main also got updated because we merged into main from our changes on B1. Okay, so what this means now, of course, is that this branch is kind of garbage, so you can unset to fix the thing. In this case, I just recommend switching out of it. And we're going to go back to main, and of course we made changes on the remote, so we have to get them. In this case, we've fetched them, but we don't have the changes. So this is when you do git pull. You can always tell because it's going to tell you to do it, of course, and because origin main is, like, our branch is behind origin main by 3 commits. And it basically means fast forwarded means you can just pull everything down and nothing's going to be merge conflicted. Or nothing's going to be, no conflict's going to happen. So we can just do git pull, and it's going to fetch from the remote branch, and you can see fast forward, there's our additions that we made to test2.py. And now git status shows you that we're up to date with origin main, and we're currently on our branch main. And we'll go to here really quick and I'll show you. B1's kind of dead anymore, like I was mentioning, so we can just do git branch-d b1 and remove it. And we can make a new change later on. Let's just say we want to make another one called b2. And we can make, more changes here, commit them, same sort of cycle. You've seen 90% at this point now what most, things do. You want to make sure that you're doing doing stuff intentionally and not, you don't want to screw anything up. If you ever have any questions, let me know, and I'll show you really quick how you can do this stuff in VS Code a lot easier. It's good to know how to do in the command line because it works. So we just make changes here, and you can see, oh wow, this is, well, this is a Python file. It's red because I'm not using Python syntax, but you can see the im modifier, which means I modified the thing. You can press this little thing, which is called source control. It's kind of what that term I was telling you about earlier called version control. And you can see when I click on it, it says I just added a line that has this stuff on it. If I want to stage it, which was the same thing as git add, I can press plus, and that stages our changes. And then if I want to make a commit to my local repository for whatever branch I'm on currently, I can type a message in here and commit it, and there you go. This also allows you to publish the branch to the remote repository in one click. And what it's going to do by default is it's going to make the name on the remote repository the same name as your current branch that you're working on your local repository. So I'll publish it, and what that's going to do is it's going to put it on GitHub, and you can see, wow, B2. This is where you'd make a pull request. So we can make a pull request. Again, this means we want to merge whatever we're done in B2 into main. And let's just say that there's no conflicts. We merge, boom. Now it's merged, delete the branch. Again, we've made remote changes. So now let's go ahead and git fetch -- prune. And we can get status. Again, you can see we removed the branch in the remote upstream. So git checkout main, git. We obviously, of course, we made updates to main, but I'm just going to remove this one really quick. Git branch -d b2, and we can then pull into main because that was made on the remote and not on ours. Git pull, everything's fast forwarded, and we're up to date. So yeah, basically you can do a lot of this in here, and it's a little faster. You can also press these 3 dots and do a lot of the commands I was telling you about, but it's easier to know how to do them on the command line, and then it makes a lot more sense for later on. So anyways, that kind of wraps it up. If you have any questions, let me know, and yeah.